In this video, I want to discuss what's called the power rule. If you have a function, the power rule for derivatives, that is, if you have a function x equal to raised to some integer power, then the derivative you will see will always be equal to this for any integer n. Okay, now we've already seen some examples of that. Okay, you've already worked it out for n equal to 2, and n equal to 2 gave you the derivative of 2x. Plug in n equal to 2 into the derivative formula that I wrote right there, and you'll see that you get 2x when n is 2. The derivative formula in the box. Okay, we also know what the derivative of 1 over x is, don't we? 1 over x is the same as n equal to minus 1, isn't it? Okay, so the derivative is minus 1 over x squared. Plug in minus 1 and you will see that indeed the boxed derivative formula for n equals minus 1 gives minus 1 over x squared. Okay, or as the formula likes to put it, minus x to the minus 2, which is the same thing. Alright, and what about if n was 0? If n was 0, then the function is 1 and the derivative is 0, and indeed if you plug in n equals 0, the derivative formula gives 0. Alright, what about the n equals 1? Then the function is x, the derivative is 1. If you plug in n equals 1 to the derivative formula, once again you get the correct derivative of 1. Okay, so there's a couple of examples. Now what if you had other exponents like 3, 4, 5, 6, 10, million, billion? Okay, let's think about what that would entail. As always, to derive the formula, you have to go back to the limit, which defines the derivative. Let me do that on the next whiteboard. So f of x equals x to the n. The derivative of x would be the limit as h goes to 0 of x plus h to the n minus x to the n over h. Now, in order to simplify that and understand what's going to happen, we need to talk about x plus h to the n. Okay, there's two ways that I can think of to understand this expansion. You might know something called Pascal's triangle. You can Google that if you've never heard of Pascal's triangle. You can also Google what's called the binomial theorem. Okay, do an internet search, and what you will find is you'll always get the following. You'll get x to the n plus nx to the n minus 1 h plus a bunch of other stuff with h's in it, and then the very last thing will be h to the n. Alright, there's some very nice patterns in there. Alright, every term, the exponent on the x part goes down by 1 as you move to the right. Every term on the h part goes up by 1. Okay, now let's plug that into our limit expression and see what happens. So on top we have x to the n plus nx to the n minus 1 times h plus a bunch of other stuff with h minus x to the n divided by h. Alright, let's see what we can do with this. So we've got some cancellation, the first and second, right? That's good. And what else do we have? Well, what would we do after we canceled the first and second? The next thing we would do is we would go and divide because everything has an h in common, we would go ahead and divide the bottom h into everything, so that would give n x to the n minus 1, and the h on that one with the h on bottom would cancel, plus you would have a bunch of other stuff with h. So let me put here a bunch of stuff with h, and I won't give you the details, but no matter what n is, you'll have some different bunch of stuff, but each term will have h in it. Okay, now the limit is as h goes to 0. Okay, you will see if you can look at the binomial theorem or the Pascal's triangle a little more carefully, you'll see that when you take they'll all have h terms, so as h goes to 0, all this stuff goes away. So the whole freak show simplifies to nx to the n minus 1. Okay, and that's the power rule formula for the derivative. All right, so the derivative of x to the n will give you that. You move the exponent down, turn it into a coefficient, and then the original exponent gets decreased by 1. All right, very important. Let's do some examples, and then I'll finish with a comment. All right, so the derivative, for example, of x to the 4 would be 4x cubed. The derivative of x to the 10 would be 10x to the 9, etc., etc. Now, I'm going to now state something without proof. Okay, the binomial theorem in the Pascal's triangle was great to prove it for natural number exponents, but I'm just going to tell you the fact that if x was something else, it's also going to work. So let's say you had like a negative 5. Okay, the derivative, it would still work the same way. All right, you still decrease it by 1. Now, what if you have even a fraction? Okay, same thing. You pull it down and you subtract 1 from the original exponent. Okay, and as it gets weirder and weirder, it's still going to work. Like, what about x to the pi power? So you bring the exponent down, decrease the original exponent by 1. Okay, now I haven't proven it for those cases, but you'll just have to accept it right now on faith that it follows the same pattern.